Good morning. This is the second of my alert videos that I'm making for my YouTube channel. The alerts are quick summaries of new articles which have been summarized in the internet web of scientific writers. If you go to my website at IVFDaily.com and choose the alerts, you do have to go through a spider check, but then you'll find just a list of links to articles which I think may be of interest to both IVF staff and IVF clients. They appear in a variety of websites where medical and scientific journalists review articles of interest to their readers and which I think may be relevant to IVF. And you can just click on those. It's all free, etc. These ones are all from Medical Express, but there's about half a dozen to a dozen links I make. Plus, also I include free links to summary articles and reviews in scientific journals or commentaries, which are open access. So it's just a little folly that I have. So there are three sessions in this one. The first one is not from one of these websites. This is from a Nature article talking about sperm sequencing reveals extensive positive selection in the male germline. Now, I have to have a disclaimer here. This is right over the top of my head. This level of genetics is well beyond me, but the message for all this is quite clear. I'll basically summarize what they're talking about, and then I'll talk about why it's important at the end. Mutations that occur in cell lineages of sperm or eggs can be transmitted to offspring. In humans, positive selection of driver mutations during spermatogenesis can increase the birth prevalence of certain developmental disorders. And this is an open access article, so you can read it, you can make sense of it. You do need to be a geneticist or a genetic researcher to really make sense of it. But these findings reveal a linear accumulation of 1.67 mutations per year per haploid genome, driven by two mutational signatures associated with human aging. In other words, the longer spermatogonia continue to make sperm, these mutations increase in prevalence year by year by year. Deep targeted and exome nanosequence of sperm samples identified more than 35,000 germline coding mutations. Makes you want to have a child. We detected 30 which were new identified under significant positive selection in the male germline that have activating or loss of function mechanisms and are involved in diverse cellular pathways. These findings shed light on germline selection biodynamics and highlight a broader, increased disease risk for children born to fathers of advanced age than previously appreciated. I think we've always recognised that as men age, not only does the sperm quality fall, but there's also increased risk of mutations. And this article is really identifying that some genes are more prone to selective pressure to increase the rate of mutation over time. And I suspect that going forward in the next whatever years, there'll be tests available to see whether the increased risk of these genes has become excessively excessive to make having children a risk. The second article appeared in American Journal of Obstetrics and Gynecology and summarised in Medical Express. And the study found that more women are freezing eggs, but fewer are returning to use them. The study found that the number of planned elective egg freezing cycles nearly quadrupled between 2014 and 2021, increasing from 4,000 to 16,000 a year. Despite this surge, only 5% of women who froze their eggs between 2014 and 2016 returned to use them within the study's period of 5 to 7 years. It may well be a bit short for some younger women. Women are now freezing their eggs at younger ages, with the average age declining from 36 in 2014 to 34 in 2021. Return rates are highest among women who froze their eggs between the ages of 38 and 42, with 7.9% of 38 to 40-year-olds, 8% of women over 40 returning to use them. 8%. Noticeably, the study also found that success rates for live birth using participants' frozen eggs were comparable to national averages for IVF using fresh eggs. This is reassuring that planned oocyte preservation can provide a good option for patients who are looking for more fertility, more family planning flexibility. And this is a publication just highlighting potential risk going down the track, 10, 15 years down the track. I don't know how long these eggs will be being frozen for, but if you're freezing eggs in your mid-30s, you may reasonably expect to use them possibly as late as your mid-40s. So most clinics will treat women up under to 45, after which there's an obstetric risk, morbidity risk of falling pregnant over 45. And there are a lot of women having their babies in their early 40s. So if you're freezing your eggs in your mid-30s, you may reasonably expect to come back in 10 years' time. However, these eggs have to be kept in storage for 10 years, and there is still not enough evidence to suggest that the viability of those eggs are exactly the same after 10 years as they were after fresh. It also creates a huge liability issue, so that if those eggs are lost or damaged in any way, women will undoubtedly claim that their fertility has been compromised, and the legal ramifications of that, I think, will be huge. And there's still also a lot of women who freeze their eggs and at the end of the time choose not to use it, and then are faced with a dilemma: should they discard, should they donate them to science or research, or donate them to another couple? And there's been quite a few articles of women not really knowing what to do, and these decisions aren't made at the time of freezing, but are made at the time 10 years later. And I think it's a quandary for a lot of women. In reality, the decision should be made right from the very start, what your intentions will be if you choose not to use them after a period of time. There's also the risk of 10 years storage, women moving on, changing their names, etc. Or I should be careful here, I'll probably say the wrong thing. But finding follow-up of women to work out what to do with eggs after 10 years is going to be a real issue. Here's something which I thought was rather interesting. It had a provocative name: when mum and dad's DNA don't match up, the embryo finds a way. This is about centromeres in eggs and sperm and how they're different. And there's quite a few publications fairly recently on sperm centromeres, and I think this one should be of interest to all embryologists. So it goes like this. When a sperm meets an egg, a lot has to go right for an embryo to develop into a complete organism. One critical step of very early development is the reorganization of parental DNA to form a new uniform genome before the embryo can undergo its first cell division. Scientists have long known that sperm eggs bundle their DNA differently. That assumption rested on the presence of a centromere protein A called SEMPA-A, a unique histone protein that marks centromeres and preserves their identity across each cell division and across generations. Because SEMPA acts like a molecular tag, preserving these sites as do not get erased regions of the genome, the centromeres are thought to be functionally indistinguishable between maternal and paternal chromosomes. To find out, the researchers tracked maternal and paternal SEMPA in the mouse embryos generated by IVF. What they saw surprised them. A second protein, SEMP-C, piled up preferentially on the father's chromosomes, acting like a recruiter. It drew extra SEMPA molecules stored in the egg cytoplasm to the paternal centromeres until the amount of SEMPA was equalized. This suggests that maternal and paternal chromosomes must equalize their centromeric strength before cell division happens, said the authors. This asymmetry in SEMPA levels is not an oddity of mice, but is also present in human, the authors note. Additionally, these levels appear to be highly variable across individual eggs and across individuals, and that to me is the standout comment. So the highlight: SEMPA asymmetry between matured gametes is conserved across flies, mice, and humans. Well, that's nice to know. Same as mice, flies. But parental asymmetry resolves before zygotic mitosis via maternal cytoplasm of SEMPA can occur. But critically, zygotic SEMPA-A levels are regulated in a pronucleus autonomous manner. SEMPA-A equalization requires an asymmetric SEMPA-C recruitment to the paternal pronucleus. So right from the outset, you can see that the quantity of SEMPA-C in an oocyte will determine the amount of SEMPA-A in the paternal pronucleus, and that delays in the first division or arrest may well cause because of things relating to insufficient SEMPA-C in the oocyte cytoplasm. This is something new to me, and once again highlights that first 24 hours is the most critical thing of all, and one that we know very little about. SEMPA-A equalization relies on the asymmetric recruitment of a maternal SEMPA-C molecules to paternal centromeres. Depletion of maternal SEMPA-A decreases total SEMPA in both pronuclei without disrupting equalization. However, in contrast, reducing maternal SEMPA-C or disruption of its dimerization function impairs SEMPA-A equalization and chromosome segregation. Therefore, maternal SEMPA-C acts as a key epigenetic regulator that resets centromeric asymmetry at the fertilization to preserve genome integrity. And I think that's very important. Just by way of finishing, my name is James Stanger. I'm an embryologist with more than 50 years' experience. I'm not a medical person, and this information is not medical advice, but hopefully it may help you in knowing what questions to ask your doctor and maybe to help in understanding the advice you receive. If you like what's going, you can subscribe, make a comment, press like, or if you really like me, you can donate some support to keep this page going at the GoFundMe page. It's also supported by my other website at FerdAid, which is an online EQA program, training program in IVF in andrology and embryology, and it allows for staff to be enrolled as trainees or professionals who can treat small clinics or large multi-lab clinics and can be used for training or competency or accreditation. And I think at that point, I will say that's enough for the week. I'll see you later. Thank you.